In this last video, we're going to be talking about the half-angle identities. What we've done so far is we started with the sum and difference identities, which allow us to find the sine, cosine, or tangent of a quantity u plus v or a quantity u minus v. We then used those sum formulas to develop the double angle formulas, which allowed us to find the sine of 2x, the cosine of 2x, and the tangent of 2x. And then the last thing that we looked at were the power reducing identities, where we then found a way to take those quadratic quantities and rewrite them in an expression that had an exponent of 1. Today we're going to be talking about the half-angle identities, and those are formed by starting with the power reducing identities that we found in the last section. So it's basically a chain going from the sum and difference into the double angles, then to the power reducing, which in turn help us develop the half-angle identities. And that's what we're looking at here in this last section. So with that in mind, I've already written here the sine squared and cosine squared power reducing identities that we proved previously. The processes that we're going to use to find the half-angle identities for sine and cosine are based on these two relationships that we already know are true. Each of these require a two-step process. What we ultimately want to start with in step 1 is to simplify that sine squared or the cosine squared into a single sine x or a cosine x, which ultimately means we need to get rid of that exponent of 2. Now we know with any quadratic expression, if you're trying to eliminate that quadratic exponent of 2, then you do that by applying a square root to both sides. And that's what we're going to do here. So in this case, when we apply square root to the left side, sine squared of x, that's going to produce a sine of x. When we take the square root on the right side, remember that whenever you take the square root of both sides of an equation, you have to have a plus or minus. So we have the same thing here. And this quantity doesn't simplify inside that square root, so we're just going to leave it there in the place of that radicand. Okay, now it's important to clarify here that this plus or minus doesn't serve the purpose of saying that the sine of x has two values. Rather, what it is saying is that the sine of x is either positive or it's negative. And you have to determine which one's appropriate based on the angle measure that x possesses. So for example, if x is a value between 0 degrees and 180 degrees, sorry about that, or if it's an angle in radians between 0 and pi, then we know that the sine of that angle has to be positive, in which case, whenever I substitute that value of x here, this whole quantity gets written as the positive result. Whereas if I'm taking an x value, an angle measure, that's between 180 degrees and 360 degrees, or it's between pi and 2 pi, then I know that that sine of that angle has to be a negative result. In which case, when we substitute in x in this position, we have to remember to make the answer negative. So the plus or minus is saying the answer is either positive or it's negative. You have to decide which one's appropriate based on the angle measure that you're given. Now the cosine squared, we're going to do the same thing with that one. So we apply the square root to both sides, in which case we'd end up with the cosine of x here, positive or negative square root of that quantity, 1 plus cosine 2x, all over 2. And there again, that plus or minus plays the same role that it did for that sine squared expression. Okay, so I mentioned that this is a twofold process. Process 1 was to apply the square root to both sides, which then is reducing that sine squared down to a single sine, or reduces this cosine squared down to a single cosine. The next thing that we want to do is some simple substitution. For this case, I'm going to say let x equal 1/2 of some value u. So there again, u is an angle measure, much like x would have been. But in this case, I'm going to substitute now into these expressions that we got in this line with the sine of x and the cosine of x. We're going to substitute 1/2 u in place of x in all positions. So what that's going to produce here, in this case, is the sine of the quantity 1/2 u is equal to plus or minus the square root of 1 minus cosine of 2 times 1/2 u all divided by 2. And we know that this 2 times 1/2 u can be simplified a bit, so let's go ahead and simplify that down. On the left side, we're left with the sine of 1/2 u. And on the right side, we've got the plus or minus 1 minus cosine. Now, when we multiply 2 times 1/2, we know that those cancel out and leave us with a 1. So that becomes 1 minus cosine u divided by 2. And this is what we call our half angle identity for sine. Now let's kind of think about why it's called a half angle. What it allows us to do is, let's say for example that I say u is a 45-degree angle. In that case, when u measures 45 degrees, I know the cosine of 45 degrees to be root 2 over 2. It's a value that is known. It's a value that's exact. So for that reason, I could substitute the square root of 2 over 2 in place of the cosine of u. I could subtract it from 1 and find a simplified expression, subtract it from 1, sorry, and find a simplified expression for that numerator. I could then divide it by 2 or multiply it by 1/2 if that's more simple in the terms of the complex fraction that I've ended up with. I can then take the square root of it, and based on what 1/2 of u would be, I can determine should my answer be positive or negative. Ultimately, what it's doing is it's saying I can take some known angle measure, some angle measure for which I know a cosine value, and from that I can substitute and simplify this right side to figure out what the sine of half of that angle would be. So if I use my 45-degree angle, for example, then I'm finding the sine of 22.5 degrees, which is half of 45 degrees. So ultimately, these allow us to then take known angle measures and work down to having an exact answer for an angle with half of that measure. Now, this is specifically the formula for sine, but it's going to look something similar to that for the cosine. So when we substitute, in this case, that 1/2 of u, then this side becomes the cosine of 1/2 u. And on the right side, 1 plus cosine of, and as we said before, when we start substituting 1/2 u in place of the x here, and we multiply it by 2, the 2 and the 1/2 are going to cancel, which is going to leave us simply with that u all divided by 2. Very similar to the sine half angle, but this is the cosine half angle. So there again, if I'm using, for example, my 45-degree angle that I was talking about, knowing that I know the cosine of 45 degrees, we can then use this formula to determine the cosine of 22.5 degrees. So ultimately what we've now determined is based on any known angle measure, we now have formulas that allow us to find the sine of the angle with half of that measure or the cosine of the angle with half of that measure. The last thing that we need to look at then is, okay, now that I know how to find the sine of 1/2 u and the cosine of 1/2 u, how can we then use that to find the tangent of 1/2 u? The tangent of 1/2 u has different forms. Much like the cosine of 2x had multiple forms when we were talking through the double angle formulas, this is similar to that. It's going to have different forms that it can take based on what's given or what's known versus what we need to find. So let's look at one variation of tangent 1/2 u. We know that with any tangent, that's equal to, by our quotient identities, the sine of that angle divided by the cosine of the angle. So in this case, if I take the sine of 1/2 u and I divide by the cosine of 1/2 u. So ultimately what I'm doing here is I'm saying take this quantity from the sine of 1/2 u and divide it by that quantity, which is the cosine of 1/2 u. Let's think about what's going to happen there. So here we'd have a plus or minus. Since they're both positive or negative, we'll talk about the relationship there in a moment. Now, we know with division, that the division, especially where fractions are concerned, division is also expressed as the product of the first quantity times the reciprocal of the second. So here, taking sine divided by cosine would be the same as taking this sine value, 1 minus cosine u all over 2, and multiplying it by the reciprocal of this cosine value, 2 over 1 plus cosine u. So ultimately, we just change that division into multiplying by the reciprocal, which is just an expression that we know from working with fractions. All right, so in this case, we can then simplify our expression. We've got a division by 2 here. We've got that 2 in the numerator. We know that that 2 over 2, when we reduce, becomes a 1, so those 2's are going to cancel. So one variation of the tangent of 1/2 u would be what we get when we simplify that and cancel out those 2's, which is this quantity. And that is one of the variations for the formula for tangent 1/2 u. So that's one of the 3 that exist for the tangent of 1/2 u, just simply formed by that quotient relationship, sine divided by cosine.